Okay, welcome to the differential equations E-schedule. Now, we just took a test in our last class, and I hope it went well for you. We are going to start with this E-schedule, Chapter 7, Laplace Transforms. Now, Laplace Transforms do a couple of things for us. One thing that they help us with is they give us another way to solve differential equations. The other thing that it does is it allows us to solve differential equations that have discontinuities in them. For example, in the last chapter we solved a bunch of problems with a mass on a spring system. And we used this as a model for it. Mx double prime plus bx prime plus kx equals a forcing. And in all of our cases, our forcing was pretty reasonable. Maybe it was a sine or a cosine wave or something like that. But the question is, what happens if our forcing is discontinuous? For example, if we force this spring for a little while by, say, going over some speed bumps in our car, and then the speed bumps stop. Or, for any reason, we start forcing this mass on a spring or this oscillator for a while, and then it stops. Or we don't force this oscillator for a while, and then after 10 seconds, we start to force it. That would be the case where we have discontinuous forcing. And eventually, Laplace transforms are going to allow us to solve these equations with a discontinuous forcing. The other example that we looked at in a previous chapter, or another example we looked at in a previous chapter, are these tank problems. And with these tank problems, we had something that looked like this. We came out with a first-order linear differential equation. Oops, that should be a T. You can go back to your notes and you'll see that when we did tank problems, we always end up with some sort of a first-order linear differential equation. This Q of t, it involved either a rate in, well, it involved a rate in and a concentration in. Remember that Ricci-Rocco equation that we talked about. Now, this can also be discontinuous. Say for 10 seconds, we send a brine into this tank that has a concentration of maybe 1 pound per gallon. And then after 10 seconds, we send in a different concentration, maybe 3 pounds per gallon of brine. That would be a discontinuous rate in or concentration in. And we can handle that with Laplace transforms as well. Okay, so the first thing that I want to start with is a definition of a Laplace transform. I'm going to go up here into my notes. So I've provided some notes on the website as well. I'm going to put a PDF up there and hopefully it'll be clear.